Hey guys, welcome back to this lecture, Implement High Availability using Mesh Cluster Implementation. In this lecture, we will learn how we can increase the availability of our Prometheus ecosystem using the Mesh Cluster mechanism, and also we will see how it works in actual. Okay, so as the entire ecosystem depends upon the Prometheus instance, we will start from that only. And as we discussed in the last lecture, like we need to implement the availability at different layers, so we will discuss what are all the layers in this case where we need to implement the availability. Okay, so let us start with the Prometheus instance. So here you can see we have two Prometheus instances running, and guys, please note all the components here are running in the containers, and in the demonstration also we will run all these components as part of container, and we will use Docker Compose to bring the entire environment up and down. Okay. So both the Prometheus, you can notice, are scraping the same targets. Okay, so basically two Prometheus instances are monitoring the targets and reporting the data or storing the data in the Promescale, as you can see in the screen. Now you'll ask, okay, both Prometheus instances are storing the data in the Promescale, but what about the duplication of data, right? So guys, Promescale handles the deduplication based on the external labels that are attached to the Prometheus instances. So if you notice, along with the Prometheus icon, you can see there are some labels I have highlighted. Okay, these are the external labels which we configure in the Prometheus configuration file. Okay, when we implement the HA cluster, and based on these labels, Promescale elects the leader, a leader Prometheus instance out of the n Prometheus instances you are running, and for that leader instance only the data gets ingested inside the Promescale storage, and the other instances just keep on monitoring but does not stores the data for those. Okay, and now if because of any reason your leader instance goes down, then the secondary instance comes into the picture, and then that is getting elected as a leader via the Promescale, and then it gets or it ingests the data inside the Promescale storage. Okay, so this was about the Prometheus and storage. Now comes to Alert Manager. So if you notice, both the Prometheus containers here are talking to both the alert managers. Okay, now you would say, now if both the Prometheus are talking to both the alert managers, so there would be two alerts that we will be getting for each and every incident. So in that case, if we implement the alert manager in mesh network, so there is a configuration for that which we will see during the demonstration. So if they are in the mesh network, so they take care of the deduplication of alerts. Okay, so now the one thing that we need to take care of when we configure the alert manager in Prometheus configuration file, what we do, we relabel the labels that are coming as part of the Prometheus container. Like you see, for deduplication at the Promescale, what we have done, or for the high availability at the Promescale level, what we have done, we have attached an external label with both the Prometheus containers. So what we will do for alert manager, we will relabel them to make them common, and then alert manager will take care of the deduplication of your alerts. So you will get only a single alert for each event, despite of there could be n number of Prometheus instances running. Okay, so this is how it works. So now in the demonstration, we will deploy each and every component in our machine, and we'll see how they communicate and how they work. And also guys, there is one more thing. Now you'll say, okay, we have used the Promescale which is running as a container. Now how do you make sure that the data stored inside Promescale is highly available? So for that, what we have done, we have mounted that to the EFS storage. Okay, so even if your Promescale container goes down, your EFS storage will be up, and you can reinstate your Promescale from that data. So this is how we can persist, or we can make our data highly available. Okay, so this was about this theory part. Now we'll jump to the demo. Okay guys, so the very first thing we will do, we'll create an EFS storage for us. So EFS is nothing but a file system based storage which AWS provides. Okay, and it's a managed service, so you need not to be worried about high availability, scalability, and durability all. So we'll create the EFS storage first, and we will mount it in our EC2 machine where our Prometheus will be running. So let me quickly go to the EFS. So let us create a file system here. I'll give it a name. Let's say time series data. Okay, you can keep it any as per your wish. I'll customize it so that I can show you the other options. You can select the storage class, automatic backups here. I don't need backup because it's just for the demo. Okay, you can enable the encryption here for rest. Now you can also customize the keys here. You want to use the AWS managed key or you want to use your own key. Okay, throughput mode is bursting enhanced. For this demo we don't need enhanced one, so we are going with bursting only. Okay, in the performance mode also again you can use the maximum IO as well, which will give you the maximum performance. Okay, here you'll select the network related things like VPC and the security groups. Okay, now these security groups are basically specified for the mount targets. So what is basically happen when we create the AFS storage, it creates you it creates the mount targets for you. Okay, and in those mount targets you can mount your machines, right? So now suppose you want to mount it from the EC2 machine, then you should have a mount target for that, and the mount target should have the security rule allowed for that particular instance from where you want to connect it. Okay, so, let me do one thing. Let us see where in which subnet our machine is, and we will enable the target mount target for that subnet only. Okay, subnet ID 856. Okay, this one I'll remove the extra one. Okay, I don't need the mount targets in other subnets. Now this is the 856. Okay, now I'll create next. I'm going with the default settings here because I don't want to restrict or allow any system policy. Okay, now I'll create the one, so it is started. Okay, now let's see. It might take some time to create your mount target, so you might have to wait for a few seconds to up to 1 or 2 minutes. Okay, it depends upon how many mount targets you are creating. If you are creating multiple, then it takes more time. So let us wait for it to complete. Okay, so we can see the mount target state has changed to available now, and we can see the security group attached to it. Now guys, we need to do one thing. We need to create a security rule in this security group to allow the NFS traffic from our EC2 instance so that we can mount it to our instance, right? So let us do one thing. Let us go first. Before doing this, let me copy the security group associated with my instance so that I'll allow the traffic from this. Okay, so this is 90.0. Okay, now let us go to security groups here. Search for this default security group 1 in 9, the first one. Now in the inbound rule, we will edit the inbound rules here, and we will create a new rule here. In the traffic type, we will have the NFS. Okay, and this is the port range and protocol, and here in the source we will have the security group of our EC2 instance, which is 90.0. If you remember the second one. Okay, so now this rule is created here now. So now our instance should be able to reach this EFS mount target at mount point at least. Now it's time we actually mount our EFS system to our machine, right? So for that, what you can do, you can go directly onto this EFS file system. You can click on this attach, and it will give you the command to attach the mount target on your system. So this is the one I'm using. Okay, so guys, one thing also we need to remember, like where do you want to mount the file system, right? So in my case, what I've done, I've created time series data directory here, and I'll use this directory to create my mount point. Okay, so let me first check whether I have anything inside this directory. Okay, so I'll use time series data to mount my file system. So let me paste it here, and in the EFS I'll replace it with the time series -data. Okay, so I will hit enter. So let it create the mount point for us. Okay, it is done. Now if I check all the mount points available in my system, time series data is also the one, and this is the size which is available for EFS. Okay, and it is mounted on our 127.0.0.1 IP. Okay, now our mount point is ready, guys. Now it's time we start working on the entire stack for our Prometheus monitoring system. Okay, so for that, let us do one thing. Okay, let us create a new directory so that we can manage the resources for that, for our Prometheus stack over there. So I'll create, let's say, Prometheus HA stack. Okay, I will go inside this. Okay, now the very first thing which I need is your Docker Compose file, which will be having the definition for all the containers. Okay, so I'll bring the Docker Compose file here quickly. So guys, I'll attach these Docker Compose file and Docker files in the resource section. You can download it from there and you can refer it. Okay, so let me create the Docker Compose file here. I'll bring the content here. Okay, so in this Docker Compose file, let me show you this as well, what all we have. Okay, so the very first thing, version, these are the volumes we are attaching for our containers. Okay, this is the one, these two is for the primary Prometheus. Okay, because we will be running two Prometheus in parallel, so we are saying it as primary and secondary. So these two mount points are for primary, these two mount points are for secondary. Now you'll say, what is config and tsdb? So one mount point I have created for the configuration related files, and the second mount point I've created for the tsdb, that is the local data of that, right? tsdb related files. Okay, now the next one, I have PostgreSQL data mount point. This is for our PromScale and db. Now alert manager config data primary and alert manager config data secondary. This is for the configuration files for alert manager. Okay, now again we will be running two alert manager in parallel. Now Grafana data, this is for Grafana files or configurations. Here Prometheus MSK discovery, I will remove it from here because in this demo we are not covering it. This is the third party component that I'll show in the upcoming lectures. Okay, and again the CloudWatch exporter config, this is again the something that we will cover in the upcoming lectures. Okay, so I will not use it in this demo for. Okay, now I'm creating the networks here, frontier and backtier, and these are the containers: Prometheus primary, Prometheus secondary, CloudWatch exporters, timescale db, PromScale, alert manager primary, alert manager secondary, Grafana, and then container exporter. Okay, now let me do one thing. Let me quickly remove the sections which I don't need in this demo. Okay, first of all, I'll remove these mount points from here. Now I'll scroll down. Okay, I don't need CloudWatch exporter here because in this demo we are not covering that. In the upcoming lectures we will see how we can do it. Okay, now this is my timescale db, this is my PromScale, this is my alert manager, primary, secondary, that's fine. We have Grafana and then container exporter. Okay, we are good. I'll save it now. Okay, so the next thing we need to take care of is Docker files for related containers. So let us see what all Docker files we need for this. So the very first, let us start from the top. Okay, so in Prometheus I'm using the Docker file path here, okay, to build the image. So I'll be using the Docker file for Prometheus containers. Next I'll be using for timescale db. Okay, same is for PromScale, and then alert manager. For alert manager I'm using the direct image, so we need not to have the Docker file for this. Okay, next Grafana, also we are using the direct image from Docker Hub, and same is for container exporter. So we need basically Prometheus, timescale db, and PromScale. So let me quickly create these Docker files here. Okay, and then we will take a step forward. So guys, to save us some time, I have created that all these directory structure here and created the Docker file for the related containers. Okay, meanwhile I've paused the video so that we can save us some time. Okay, now I'll show you what I've done. So the very first Docker file we have created for the Prometheus, I'll just get it open for you so that you can understand it. Okay, here we are using the Prometheus image. Okay, and these are the command arguments which I am passing. Web config is for the web UI. Okay, these are the console and libraries which I want to mount, and this here I'm setting the storage TSDB retention. So this particular argument has been deprecated now. I just added it here to inform you about that. The new argument that you can pass is -- storage.tsdb.retention.time. Okay, I'm setting it up as 1 hour. What does that mean? That the local TSDB storage now will be stored for the, or will be kept for the 1 hour, last 1 hour. Okay, before the old data will be deleted. Now this is the storage TSDB path which I have mounted. Okay, which I have created in the container. Okay, which I specified it here, and this is the configuration file inside the container. Okay, now I'll show you the Docker file from PromeScale. In the PromeScale Docker file, I have used this image timescale PromeScale latest. Okay, and these are the command arguments I passed. I've used the DB password, DB port, DB name, DB host, and DB SSL mode allowed, and I ran it with the metrics high availability flag. So it basically tells the PromeScale to run it in high availability, and it allows to take the data from multiple Prometheus instances and select the leader and elect the leader from one out of them and ingest the data for one only. So this is the flag which is required for high availability in the PromeScale, and the port number which we have exposed for this is 9201. Okay, now next we will see the Docker file for timescale DB. Okay, in this Docker file we have used this particular image for Postgres. Okay, and the command we have passed is Postgres, and then synchronous commit off, and this is the port we have exposed for it, 5432. So guys, this is the timescale DB container is basically the actual DB that is running behind, and this PromeScale is the extension which is running over the timescale DB, and which is providing you the which is working as a connector for you, so that your Prometheus instance can connect to the PromeScale DB, right? Or you can say timescale DB in the backend via connector. So PromeScale works in between them. Okay, so we are good with all the Docker files now. Now let us do one thing. Let us run the stack and let's see if it is working or we are getting any issue. Okay, so for that, let us check if we have other containers already running. Okay, before that I will have to start Docker itself. So let me start it. So you can enable it as well, guys. So you can use systemctl enable Docker. So what will happen, whenever your server will come up, your Docker daemon will automatically start in the backend. Okay, now it's time we check the running Docker containers. Okay, these containers are running. So let us do one thing quickly. Let us stop these containers so that we do not have the multiple containers, right? So it will create the confusion. So let us go to the old configuration. What was the path of that? Let me quickly rewind it. Okay, it was in Prometheus-stack. Okay, now I will bring it down. So all the containers created as part of this stack will be stopped. Now guys, I have intentionally left a few configurations which we need to do, and I'll show you as the part of this implementation so that you can understand what actually happens here. Okay, so let us go to our new directory. It is Prometheus HA stack. Okay, and now here I'll run docker compose up -d. Okay, okay guys, so I can see all these informations here. Okay, these are the logs of this docker compose build. I can see volumes are created and the containers are created now. So let us do one thing. Let us check the running containers here. Okay, that's great. We can see the containers are created, but we are also seeing few of the containers are in restarting state. Do we know what actually happened here? So if you notice, the containers which are restarting are basically Prometheus containers, and the alert manager containers. Okay, apart from that, the other containers are up and running fine. So now let me tell you one thing, guys. When we use Docker Compose, okay, so what we are saying it in the alert manager case, we have mounted our configuration, right, configuration directory with this particular path. Okay, the same is the case with the Prometheus. So we have mounted the configuration file over the local host system. So here it is. So the config data etc Prometheus, it is mounted with this path in the local host. Now if I go in these volumes here, so these location for these should be where lib docker volumes, and here if you notice, let us take an example of Prometheus first. Prometheus HS tag Prometheus config data. Okay, so let me go inside that HS tag Prometheus config data primary. Okay, let's go inside underscore data. Now here, this is the Prometheus YAML file which came by default as part of the container, which was actually the part of image. Okay, and this is the container file, Prometheus file that came over here. Now if we read this prometheus.yaml file, it does not have alert manager configuration, right? Here it is trying to scrap the host on localhost 9090. Okay, now let me do one thing. Let us check the logs of this Prometheus and see what is the issue it is facing. What it is saying, unable to validate web configuration file. Open etc prometheus web config.yaml, no such file or directory. Now guys, this is happening because in our Docker Compose file, or in our Docker file for Prometheus actually, let me quickly take you back over the Docker file which we've used for the Prometheus. So it was in opt prometheus HS tag and then Docker file. Okay, let me cat it here. So here in the web config file parameter or argument, we have passed the web config YAML file to this process, right? But in our mount point and also inside the container, it is not able to find this file. Then how come it will come up, right? That is the issue it is facing, and now we need to resolve it. So what we will do, we will create a web config file inside the host mount, and it will be picked by the container. So let me quickly create it. So we are currently in the primary container. Okay, I'll create a web-config.yaml file. Bring the content here quickly. Okay, so let us quickly bring this content from the last implementation that we have done from the Prometheus, because we will be using the same password and everything. Okay, it was in MNT Prometheus stack, and then it was okay, it should be in the mount targets, where the volumes where it was mounted earlier. So it should be in the where lib docker volume, and then we have Prometheus stack. Okay, now we need Prometheus config data, and then we need web config file for this. Okay, so what I'll do, I'll directly copy it inside our new containers, where lib docker volume Prometheus stack Prometheus, it is Prometheus HJ stack, the new container. Okay, this path has become really big here, but don't worry about it. You can use the other ways as well. So I'll just copy it directly there, because the same web config will be using in this setup as well. Okay, I'll overwrite it because I've created an empty file over there, so it will be overridden, and the same config file I'll be using for the secondary as well. So let me just replace this primary with the secondary. Okay, now let me check. So we got the web config YAML here. Let us read this. Okay, so we are just using the basic auth user and password. Okay, now the same is with the different secondary Prometheus container. Now guys, there is one more thing that we need to do is, because the Prometheus YAML file that is coming as part of the container is very default one, right? So we need to update it with the updated one, which we need for our Prometheus setup, for this high availability setup, right? So what I'll do, I will replace this file with the new content. So I'll empty it first and then I will copy it here. So let me bring the content here quickly. Okay. Now the same configuration file, because in the high availability cluster setup, what we need the two identical Prometheus instances with the same configuration, right? So what I'll do, I'll copy this prometheus.yaml file inside the secondary container as well. Config secondary data, and then I'll copy it here, and it will replace the existing one. That's fine. So what there is, guys, if you remember from the architect diagram, so there to get the high availability at the storage level, what we need an external label associated with your Prometheus instance. Okay, and in that external label, there are two things I'll show you which we need. Okay, I'll go to secondary Prometheus instance here, because I want to update that external label in secondary. Update the Prometheus YAML. Here, if you notice this, we have these two external labels, replica and cluster. Okay, so guys, to attain or to get the high availability at the storage level, what we need all the Prometheus instances running in your cluster being part of the same cluster. Okay, so the cluster name will be common for all, and this cluster underscore replica underscore, this should be the unique identifier for each and every Prometheus instance. Okay, so what I'm using for primary, I'm using prom1, and for secondary, I'm using prom2. Okay, I will update it here now. Okay, so we have done the configuration at the Prometheus side. Now let us see what is the status of containers for Prometheus. Okay, both the Prometheus containers are up now. Okay, both are reading its configuration fine, so they are up. Now it's time we resolve the issue with the alert manager. So let us check the logs of this alert manager and let's see what logs it is throwing. Okay, it is saying open OPT Bitnami alert manager web config YAML, no such file or directory. That's fine. Again, the same issue, because the default image does not have the web config YAML file, web config implemented, right? So we have done it using the Docker file. So what we will do, we will pass this web config file from the older setup to the new containers. Okay, so let me quickly copy the web config file from alert manager, volumes, Prometheus stack. So this is the path of old containers. Okay, old containers volume which we mounted on localhost. That should be alert manager. Okay, data, now web config, and I'll copy it where lib. Okay, I think, yeah, that's fine. Where lib docker volume Prometheus stack alert manager primary data. I'll copy it here. The same way I will copy for the secondary as well. Okay guys, now I would like you to listen it very carefully, guys. So there is one change in alert manager configuration file this time to run them in the mesh network, right? So that they can support each other and they can support the deduplication. So what we need for that in the alert manager configuration, let me show you. Okay, so this is the default one. Let us quickly replace it as well with the new alert manager configuration file. Okay, so let me bring it here. First I'll empty it. then I will bring the new content inside this file. Okay, so guys, here these are the receivers, routes, and the SMTP related details. I've replaced it with the new one. Okay, now the same I'll copy in the second container as well. Prometheus HS tag, alert manager, secondary data, and then copy it. It will override it. That's fine. Okay. Now we have web config as well, so I'll copy this web config as well in the second container for alert manager. Okay, just let me specify the source file here. I forgot that. Okay, it was already there. Okay, so now both the alert managers have config and web config YAML file. Now guys, I'll show you one thing. Let us go to our original source code. Okay, in the Docker, in the alert manager. Okay, Prometheus HS tag, and I want to read the Docker compose file for this. Go to here let us go to alert manager section, and in the alert manager section, if you check the commands here, okay, first we have given the config file path, then web config file path, and then -fn cluster.pr. So guys, this argument is used to run the alert manager in mesh network. So what we are saying, both the containers, both the alert managers are in peer here, okay, and on the path they are running. Okay, so 90904 path port number is used for the peering. So what happens if you enable this peer? Now suppose you create a silence in one of the container or one of the alert manager container, the silence will be applied in the second container automatically. Okay, and also if they are in peer, if an alert is coming to first container, so second will be able to deduplicate it or will prevent the alert from the second one. So only a single notification will be sent. So this is how they work in the peering, guys. So I wanted to show you this configuration. This is really required to run them in the peering. Okay, now let us check the container status. Okay, great, all the containers are running fine now. Okay, all are up. Now let us check the Prometheus console. Let us go to instances. I'll open it in 9090. Okay, I'll pass the username and password. Okay guys, so here in the Prometheus console, let us check the targets here. So in the targets we can see there is only one Prometheus endpoint which is down, so it seems like it has not picked the new configuration we have posed. Let us go to configuration section. Okay, we can see it is the old configuration. So now the reason, what could be the reason behind it, that we have given it a new configuration file, and post that we have not restarted the container, that's why it was not able to pick the new one. Okay, so let us do one thing, let us restart both the Prometheus containers, and the same case with alert manager as well we will do. Okay, same with alert manager, let us do that so that the changes reflects. So let us check if the containers are up and running. Okay, all the containers are up and running. I'll refresh it here. Okay, seems like it has taken the new configuration now. Okay, let's go to the targets here. Let it get resolved. So we can see both two Prometheus containers here. Okay, both are up and fine, and these are the labels. Okay, that's looking really great. We can see the node here. JMX exporter, container exporter are currently down because we have not configured them properly for this demo, because it was not our purpose of this demo, so we'll keep it as it is. Okay, now it's time we see the remote metric and see if the data is getting written to the remote storage. Okay, that's great. We can see there are these two connections, okay, with the same job, Prometheus. This is the remote name, and in both the cases the number of shards are 4. So that's seems like the data is getting pushed to the remote storage. Okay, and we can also check the TSDB status here. Okay, so this is the current number of series and number of chunks in your TSDB local storage of the Prometheus. Okay, now let me show you one more thing. So we have set up the 1 hour as the data retention for TSDB, right? So I would like you to see that over here as well. Let us check for the retention time. TSDB retention. Okay, so this is the flag, and we can see it is 1 hour and the path is /Prometheus. Okay, so our configuration is really reflecting here, so that is a good indication. Now let us see on which port the other container is running, 9091. Let us open that as well. Okay guys, so we need to make sure that our security rules are allowed for these ports which we want to access. Okay, so we need 9091. 9090 is already open, and then 2 we need for alert managers, 9092 and 9093. So these are the ports I'll allow quickly in the security group. 9090 is there, 9091, 9092, 9093. So I'll add a rule here. I'll make it 9091 up to 9093 from my IP. Let's see if it takes the range. Okay, now let us refresh it. Okay, it opened, and let me pass the credentials here. Okay, now the next thing we need is alert manager on 9092 and 9093 port number. I'll pass the credentials here. That's fine. Same is with secondary alert manager. Okay, now we will test one thing. We will see the configuration of these alert managers, whether they are reflecting the changes which were made in the image. Okay, so let us go to status here. It is ready. Okay, uptime we can see, name is this, and here in the peers section you can see there are 2 alert managers here. Okay, so this is what we have passed in the Docker file of alert manager, where we were creating the peer. Okay, we have passed that peer configuration. You can see it here as well. Okay, that was in the Docker file, not the configuration. Okay, so you cannot see it here. Okay, so you can see both the containers are running in peers here. So that means if we'll apply silence in one alert manager, it should be reflected in the second as well. So let us try that. I'll create a silence here. I'll give it any name, let's say. Let me make it like environment equals to production. Now I'll create it. But it is saying please complete adding the matcher. Okay, I'll add it here. I've not added it. Okay, so now I've created a silence here. Okay, silence is created here. Now let us go to the second alert manager and let's see whether it is visible over there as well or not. Let me refresh it. Let's go to silences. Okay, so your silence is created here as well. Okay, so this makes them to be run in the pairing, and both are providing the alert manager high availability. Now suppose if one of the alert manager goes down as well, your second will be keep on working and you'll get the notification as intended to be. Okay, The same is the case with Prometheus primary and secondary as well. If your Prometheus primary goes down, the second will continue working and hence will provide you the high availability. Okay, now guys, the highlights that I would like to repeat again is, so here if you have noticed, we have implemented the high availability at different layers, right? We started with Prometheus, then we have seen alert manager, then we have seen storage. Okay, now the highlights are, for HA availability, using the strategy we have used in this implementation, we are running two Prometheus in parallel. Okay, both are having the same configuration file. The difference between two Prometheus containers with respect to the storage is that we are applying an external label in both the containers. Okay, the external label we need so as to tell the Prom scale connector to enable the high availability at the storage perspective. I'll explain you in a bit. Okay, now the next thing, we have two alert managers, both are running in parallel, both are running in peers. Okay, at 9094 port number. Okay, now comes to storage, and also come back to alert manager again. So alert manager manages your silences, they manages your deduplication of alerts. So if both the Prometheus containers are throwing the alerts to alert manager, it's job of alert manager to send one notification only, and that becomes possible for high availability using the peer. And also, if you remember, in the alert manager configuration, we have used the relabeling. Okay, so now guys, what happens basically, it is the nature of alert manager that if multiple alerts are coming with the same labels, okay, that means it will send the one alert for that. Now it can come from multiple Prometheus instance as well. So what is happening now, suppose both the Prometheus containers are throwing alert to alert manager. Okay, now one label that is different in both the Prometheus is the replica label, which we implemented for the storage Prom's high availability. Okay, so what we will do in alert manager, we will reuse the relabeling here. So in that relabeling, what we are basically doing is we are relabeling that demo 1 and demo 2 as demo here. Okay, so the labels are replaced with the demo string. So now in that case, if two alerts are coming from both the Prometheus, both are having the same labels. Okay, that means alert manager will take care of it and will consider it as a one notification only, and will send you the one email notification. So this is how alert manager deduplicates the data or alert. Okay, now comes to storage. So for PromiScale to run as in a high availability, what you need the external labels to be associated with the Prometheus, and based on those external labels, PromiScale selects or elects one leader out of those. Okay, and will only ingest the data for the leader Prometheus instance, and for the other instance it will not ingest the data. Now suppose by any chance your Prometheus leader goes down, then the next Prometheus will be elected as the leader and the data storage will continue. Okay, so this is how high availability works in PromiScale and PromiScale Timescale DB. So guys, we were able to implement this highly available architecture for using Prometheus, PromiScale and alert manager. Also you had the Grafana for the visualization. Okay, now guys, there is one more thing. Now because we have multiple Prometheus, right? So in the Grafana, which data source you will use? Would you use the Prometheus primary or Prometheus secondary, or you would use both? What makes sense? So guys, in this case, it doesn't make sense to use the Prometheus, any individual Prometheus as the data source, because if your container is going down, then your virtualization or visualization, then your visualization will also be down. So in that case, what you will do, you will use the Timescale DB as the, or say a PromiScale as the data source in Grafana. Okay, and then you'll set up the visualization on that. So we can try that as well. Just give me a minute and open it. So it is running at 80 port. Let me quickly enable the 80 port if you already have. Okay, we already have enabled it. So let us go to okay guys, so our Grafana is up and working now. So let us quickly log in to this console. I'm using the default password. I'll log in. Okay, so my Grafana console is up. Now let us create a data source here quickly for the ProMiScale, and let us see whether we are able to visualize the data. Okay, I'll use the time series database is here. I'll select the Prometheus, and here in the URL I will pass HTTP. Then the container name, because my container Prometheus container identifies the container name. Okay, and I'll pass the port number ProMiScale 9201, and then I'll keep the default settings and I'll save and test it. Okay, my data source is up and running, means communication between the Prometheus and your ProMiScale is fine. Okay, so now let us quickly go to explore and let us see if we are getting the metrics for this data source. You can see the data source here. Now in the metrics, okay, we are able to see the metrics here fine. Okay, let us check any of the metric here. Okay, so we are seeing the data, it's really working great. So we were able to create the visualization now, guys, and we can see the data is coming up here. So it means our integration is working fine between ProMiScale and Grafana. Okay, now the next thing which I would want to see you is that if you remember at the very starting, we have created a mount point for the EFS, okay, in our local file system. So let us see whether my ProMiScale is storing data over the EFS or not. Okay, so let us, if you remember, we have given the path as /time series data. So let us go to that directory and let us put list here. Okay, so we can see all the Postgres related data is available here, means your database related all the files are persisting in the EFS now. So even if my container goes down, my data will be available here, and you can reinstate your ProMiScale container or your DB or the storage in your cluster. Okay, so this is how EFS can help us in persisting the data, and also it will be highly available, so it will not be impacted if your container goes down itself. Okay guys, so this was about this lecture. In this lecture we have implemented the high availability at different layers, and we have seen how we can perform the different things. Okay, in the upcoming lectures we will take a step forward and will understand the other aspects as well. So I will see you in the next lecture. Thank you.